these are the notes for understanding chemical reactions and parts of chemical equations. And so we've already talked about and established that atoms can bond together and make molecules. Well, sometimes, I would ask, why are there so many different kinds of molecules? And the answer lies in that molecules can change. Bonds can form, but bonds can also, so they can form, but they can also break. And if they break and there's another atom around, they could make new molecules, right? And so those are chemical changes. We started with one molecule, and then we rearrange the atoms, new bonds form, and that makes new molecules. And so those are chemical changes or chemical reactions. And so a chemical equation is a symbolic representation of a chemical reaction. And so that, my yellow highlighter. Chemical reaction is when molecules rearrange. So there has to be molecules breaking apart and forming new molecules in order for a chemical reaction to occur. And we represent that by writing a chemical equation. So just remember, the subscript is that little number, tells how many elements there are in one molecule. The coefficient is the big number, and that tells the molecule number. That does not look good. It tells molecule number. Okay, so you've probably seen a chemical reaction like this, right, or a chemical equation, and there's some vocabulary that we got to tie to this. And so the first thing is the reactants, and that is the stuff you start with. So starting molecule, put in parentheses S, because you might start with one molecule. If it's a big one, it could rearrange and make smaller ones, or you might start with many molecules. So it's what you start with, the starting stuff. And so you would read this as the reactants react to form the products, right? And that is the ending molecules. So this is what we start with. So I think the reactants react to form products. You might also think the end product, right? The product is what you turn in. That is the end result. Okay, so how do we understand these chemical reactions? So we've already established that these are the reactants here. These are the products. Well, one thing that I think students should do is figure out how many atoms you have in each side. And so if you remember from our practice the other day, if we want to know how many reactants, how many carbons are in our reactants, right? So there's 6 in one molecule of carbon dioxide, but if we have 6 of them, then that means that there are 6 carbons. Okay, hydrogens, there are 2 in one water molecule, but we have 6 water molecules, so 6 times 2 is 12. And then oxygens, so we have these oxygens, so in one molecule of carbon dioxide there's 2. 2 times 6 is 12. But then there's also some oxygen in the water molecules, right? And so if you have there's 1 in one water molecule times 6, that's 6. When you add those together, there's 12 and 6, there are 18. Okay, and so let's visualize this, and that's what I did down here for you guys. So again, these are our reactants. And so we have our 6 carbon dioxide and plus, so that reacts with 6 water molecules. And so we're actually going to color these, right? And so just like we did in our lesson the other day, right, the carbon dioxide and the water, we're going to color those the same way. And so we have these carbons, and then we have oxygens, And then we have our 6 water molecules, which have, each one has 1 oxygen and 2 hydrogens. Okay, so in our reactants, we have 1, 2, 3, 4, 5, 6 carbons. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 oxygens, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons. Yes, that is correct. Okay, I can count. Now let's look at the products, okay? And so what we're saying is that we started with these molecules, right? And there's lots more to this reaction, but they're going to break apart and they're going to rearrange, and then they're going to reform as these new or different molecules, right? And so over here we have 6 carbons in our products. We have 12 hydrogens, and then we have 6 oxygens plus 12 oxygens, right, which is 18. And so this is that same crazy molecule that we did the other day. So carbon, 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 carbon. And then we have oxygen, 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 oxygen. And so part of our reactants, or sorry, our products, is this molecule, C6, I can't write, C6H12O6, and that is glucose, which is sugar. And then over here we have 6 oxygen molecules, and so all of these are oxygen. It's oxygen gas. And if we count, we should be able to get the same. So 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 oxygens. Okay, so let's see if you guys know what this reaction is. All right, we start with carbon dioxide, what you exhale, in water, and it reacts to make sugar and oxygen gas. You've actually seen this reaction before if you had my class last year. This is photosynthesis. Simplified. There's actually like a lot of steps in between here, but you guys get the point, right? And so you see also that what you start with, the atoms, is what you end with. You don't start with the same molecules, but you start with the same atoms. Okay, and that is what we call the conservation, law of conservation of mass, which means that in chemical reactions, we don't gain or lose atoms. What we start with in our chemical reaction is what we end with. Okay, if you guys have any questions, let me know.